Hello and welcome to the presentation, Science with Small Cameras, Visual Monitoring Camera on board Mars Express. My name is Eleni Ravanis and I spent 2 years working for the Mars Express mission, although I'm now at the University of Hawaii at Manoa. Today I'm going to be talking to you on behalf of the Visual Monitoring Camera team. Here you can see a collage of some of our favourite images taken with the instrument. Okay, so what is the Visual Monitoring Camera, or VMC for short? First, a bit of history. The VMC was originally an engineering camera on the ESA Mars Express mission that was designed to monitor the release of the Beagle 2 lander. It did this in 2003 when Mars Express reached Mars, but then in 2007 the camera was switched back on again in order to be used for outreach purposes. Then, after the VMC was successfully used for the analysis of limb clouds on Mars, the instrument was upgraded to the status of a scientific instrument in 2016. The camera itself is a 640 by 480 pixel camera with a wide field of view, and the instrument itself is small, and the entire unit is less than 11 by 6.5 centimeters. You can see a euro coin in the photo for scale. Since the upgrade of the VMC instrument in 2016, the VMC team has been working on calibration and a data processing pipeline for the VMC camera. In October 2020, all the VMC data from 2007 to mid-2020, as well as the observations taken of the Beagle 2 lander in 2003, were archived and made public on the ESA Planetary Science Archive. The current dataset totals some 50,000 images across more than 3,000 observations. What do those 3,000 observations look like? VMC can take a variety of observations. The wide field of view allows VMC to capture the entire disk of Mars within the image when observing from near the epicenter of the Mars Express orbit, as seen in panel 1 of the figure on the left. The wide field of view also allows us to perform observations over a wide portion of the Martian limb, as seen in panels 3 and 4 of the figure. When we combine this with the elliptical orbit of Mars Express, this enables observations of large regions of Mars at different local times and distances. Okay, so here is a video put together using VMC images of a full Mars Express orbit as seen by VMC. And it gives you a flavour of some of the kinds of observations that are possible at different distances. Okay, how does this compare to other cameras in orbit around Mars? In the past 2 decades, most of the observations at Mars have been acquired by spacecraft in sun-synchronous orbits, centred at the local afternoon. And that creates a bias in the study of early morning atmospheric phenomena, which we'll return to later. Importantly, Mars Express was the only mission in a non-sun synchronous orbit until NASA's MAVEN spacecraft and India Space Research Organisation's Mars Orbiter mission arrived in 2014. ESA's ExoMars Trace Gas Orbiter arrived in 2016 and started science operations in 2018 and is also in a non-sun synchronous orbit. As for the wide field of view of VMC, other cameras in orbit around Mars with a comparable field of view are the Mars Color Camera on the Mars Orbiter mission and the Mars Color Imager MARCI on the Mars Reconnaissance Orbiter. However, it's worth noting that MARCI cannot capture full disk images due to the orbit of MRO. So the point is that the observations we can take with VMC are made possible due to a combination of its wide field of view and the specific parameters of the Mars Express orbit. What kind of science can we do with VMC? VMC data has been used for the analysis of a seasonally recurrent annular cyclone with an accompanying vortex in the North Polar region, analysis of regional and global scale dust storms, clouds in the Martian twilight, and aerosols in the Martian atmosphere, to list just a few examples. If you want to learn more about that, you can check out the following publications and presentations listed here. Now let's turn to one particular science example. We mentioned previously that over the past 2 decades, most of the observations at Mars have been acquired by spacecraft in sun-synchronous orbits centred at the local afternoon, and that creates a bias in the study of early morning atmospheric phenomena. So an important example of the science that has been possible with VMC data is the study of the Artio Mons elongated cloud, or AMEC for short. The VMC science team observed an extremely elongated cloud extending up to 1,800 kilometers westward from the Artio Mons volcano following the global dust storm in Martian year 34, which was 2018. A similar cloud was then found in the same season in different years in archive images of VMC and returned in 2020. The AMEC forms in the early morning, with growth starting before sunrise and then extension westwards for roughly 2.5 hours. The cloud then detaches from its formation point and continues moving westwards until it evaporates before the afternoon, when most sun-synchronous orbiters observe. The VMC camera was particularly suited to studying this phenomenon because the orbit of Mars Express allowed us to observe in the early morning, and the large field of view allowed us to image a large portion of Mars, thus allowing us to capture this extremely large cloud. Our upcoming study, led by Jorge Hernandez Bernal, is in the latter stages of review as of November 2020, and uses VMC data as well as data from 6 other instruments to study this cloud. So keep an eye out for that paper if you're interested. Finally, it's worth mentioning the high temporal resolution of VMC images, which are taken roughly every 48 seconds. This allows the team to produce mosaics and videos showing the movements of aerosols in the Martian atmosphere. So, here is an example of a dust storm over the North Pole of Mars captured in May 2019. Okay. So the point we're making is that the VMC instrument is an example of a small camera that has yielded high science returns. Now, how does this relate to priorities for future Mars exploration and the wider theme of planetary instruments for this session? Well, to examine that, I'd like to draw your attention to 2 recent documents. The first is a report published in November 2020 from the Mars Exploration Program Analysis Group, MEPAG, and states that the ongoing rapid development of small spacecraft has the potential to provide a new means of exploring Mars with more affordable and more frequent flights of payloads for scientific measurements and support of human exploration needs. And the extensive use of small spacecraft at Mars is particularly appealing during an otherwise Mars sample return focused decade. I think that last point about this being an otherwise Mars sample return focused decade is a really important one, because it's going to prompt us to look at other lower cost ways to continue Mars exploration science, including atmospheric science at Mars. The second document is one of many white papers that were submitted to the recent US Planetary Science and Astrobiology Decadal Survey. And this paper was focused on the high science value return of small spacecraft at Mars. This paper advocates for a new programmatic framework for low-cost missions in the range of $100 to $300 million, based on the high potential science return of small spacecraft missions, again citing this idea of still getting frequent access to Mars in an era of Mars sample return and beyond. So here we see a need from the Mars community for new, lower-cost ways to do science at Mars, particularly now that we're entering a decade focused on Mars sample return. The last thing I want to draw your attention to before wrapping all of this up is the idea of data volume and competition for antenna time on ground station networks. In the early days of Mars exploration, we didn't have many spacecraft at Mars, so there was less competition for ground station resources. Now, all being well, we're going to have the most spacecraft at Mars that we've ever had, essentially. And whilst that is amazing, that does mean competition for antenna time on both the NASA's Deep Space Network and the ESA's S-Track network to some extent. This did actually prompt ESA this year to control 2 spacecraft with 1 antenna dish for the first time, these spacecraft being Mars Express and the ExoMars Trace Gas Orbiter, so that we can make our ground station resources go further in future. So with more spacecraft competing to use the networks, that becomes an issue for the Mars missions, which need to use the large antennas. So we start looking at a trade-off when it comes to taking observations between the resolution of the images, the data volume they take, and the data volume they take up. And it's worth noting that the data volume of VMC images is small, which means that we can store and receive images even when data rates are very low. If many new small spacecraft missions launch, there will likely be a lag in making the changes to the ground stations, and therefore even higher demand put on antenna time. So if useful science can be done with low data volume, then that's a good thing. So what can we take from VMC going forward? The point is that VMC, once intended as an engineering camera and now used as a science instrument, is essentially a proven case of a small, low-cost camera that has yielded high scientific return. The non-sun synchronous elliptical orbit of Mars Express, coupled with the wide field of view of the VMC camera, has allowed us to explore previously unnoticed atmospheric phenomena such as the RTMON's elongated cloud. And this idea of orbit plus field of view is something worth considering for future missions focused on investigating large-scale atmospheric processes on Mars. The small physical size plus the low data volume of VMC images is appealing for future small spacecraft missions where competition for both payload space and antenna time will be fierce. So to summarise, VMC was originally an engineering camera and is now a scientific instrument. The combination of the wide field of view of VMC plus the orbit of Mars Express has allowed for the study of diverse atmospheric phenomena. Observations from VMC have been used to analyse the 2018 global dust storm, plumes on Mars, limb clouds, twilight clouds, and an elongated cloud over Artemons, and many more. The scientific success of this instrument around Mars highlights how small cameras on planetary missions can yield high science return. We therefore suggest that future missions would benefit from the inclusion of a VMC-like camera, taking into account the hardware improvements made over the last 2 decades. And here at the bottom is a collage of some of the rest of our favourite images from VMC. Thank you very much for listening and taking an interest in VMC. If you are interested in learning more about VMC, please don't hesitate to contact me. And remember, VMC science data is available on the ESA Planetary Science Archive and is also regularly uploaded to Flickr and Twitter, sometimes within days of the images being taken at Mars. Thanks again for listening and enjoy the COSPAR conference.